This example is going to show us how to use normal distribution in the empirical rule to figure out how many fall within a certain range. Not just what percent fall within a certain range, but how many actual data values, or in this case, how many students fall within whatever specified range we're discussing. Okay? So, same problem we looked at last time. We've already got our normal curve filled in down here. Right? And what we're looking at is the 2018 results on the SAT. All right, what our problem is telling us up here is that 2,136,539 students took the SAT in 2019. There was an average score of 1068 and a standard deviation of 204. Right, so 2,136,539. Right, that's our number of students that took the tests. Our mu, or our mean, is 1068, and our sigma, the standard deviation, is 204. Right, and so we're going to take our mean and we're going to stick it right in the middle of our graph. Right, and we're adding 204, right, just like we did in the last example, to find the different values. Okay, 1068 plus 204 is 1272. Right, one standard deviation above the mean. Right, well, that happens to be the value that they're asking us about, 1272. Right, what percentage of students scored better than a 1272? Right, so what percentage? In approximately how many students, we're missing the how, but how many students scored better than a 1272, right? So percent versus how many, right? And what you're going to find out is to figure out how many, we're going to actually need the percent. So these two things go hand in hand, okay? Now, to start filling this out, remember our empirical rule. It said that 68% of the data falls within one standard deviation, 95% within two standard deviations, and 99.7 within three standard deviations. Right? Those values could be broken down into the individual sections of 34%, 13.5%, 2.35%, and 0.15%. Okay? So if we look at our graph, there's your 34% and your 34%. Right? 13.5 and 13.5, 2.35, 2.35, and then of course 0.15. Okay, all percentages, percent, so on and so forth. Okay. Now, what percentage of students scored better than a 1272? Well, better than would be above this. So we're talking about these three sections of our graph right there. So the percents, all we need to do is add those up. What is 13.5% plus 2.35% plus 0.15%, and that gives us 16%. Right? So 16% of the students that took this SAT scored better than a 1272. Okay? We can use that value to figure out how many of the students that's talking about. Okay? And so we can't actually use the percent, but we can use the probability that's related with that percent. Right? The how many is going to equal the total number of students, right, times the probability. Well, this is your probability as a percent, but you can't plug a percent into a calculator. So remember, we can multiply by 100, or AKA we can move the decimal over two places, but 16% is 0.16 as a decimal. Right? That is the probability of scoring greater than 1272 on the SAT in 2018. Okay. Come over here and let's plug in. We know our total. We already kind of did that at the beginning, right? 2,136, so on. Plug that in first. 2,136,539. times the probability, which was 0.16. Right? And so that's going to give us 2136,539 times 0.16, approximately 341,846, right? And you can't have 0.2 people take the test. So what this data is telling us essentially is that we can say that around this many people took the test. This would be a good time to stop the video and copy down a few examples. The next problem we're going to look at here is asking us a similar question. Right? We're looking at the same set of data, 2018 SAT scores. We've already got the same normal curve already set up. But this time, instead of asking us how many students scored above a certain value, they're asking us approximately how many students score between 660 and 1068. Okay, so same idea. Let's come down to our graph and say, well, we've got our 660 here, we've got our 1068 right there. Right? The 1068 is our mean. 660 is 2 standard deviations below the mean. Right? So same thing we just did last time. Right? Look at our empirical rule. Right? 68%, 95%, and 99.7%. Break that down into the individual sections of 34%, 13.5%, 2.35%, and 0.15%. Right? And we don't actually need to fill in the whole thing. We could just fill in the sections that we're looking for. Right? They want to know between, right, 660 and 1068. So really, we only need these two sections of the graph to figure out what we're looking for. Okay. Well, 68%, or the 34 and the 34, that gives us one of our sections. The 13.5%, that gives us our second section. And so we can pretty much stop right there. Those are the two sections that are between the two values we're looking at, 660 and 1068. And so approximately how many students would be, once again, the how many part is the total number of students times the probability as a decimal. So we need to do what we did in the last example. Find the probability, or find the percent, turn it into a probability, and then multiply that by the total, okay, of 2,136,000 students. All right, so we'll take a look at it and we say 34% plus 13.5% is equal to 47.5%. Okay, so 47.5% of our students scored between 660 and a 1068. Okay, we'll turn that into a decimal. 47.5%, if we move the decimal over 2, is 0.475 as a probability, right? So that's what's going to go in there, right? The 2 million students, that's what's going to get plugged into your total. All right, and so how many students score between 660 and 1068 is equivalent to 2,136,539 times 0.475. Let's see, one thing is I love about TI, second enter, change this to 0.475. 475. And we see that that gives us approximately 1,014,856. Ta-da.